Welcome, everyone. My name is Kat Pullen, and I am a member of the marketing team here at Cohesive. Thank you for joining us today. As a full asset management lifecycle consultancy, we bring together experts and tools along an assets roadmap from bidding to retirement. Today, we'll be discussing your asset reliability journey. We'll be muting the phone lines during the presentation. If you have a question, please enter it in the question box, and we will read it at the end of the presentation. This webinar is being recorded, and we will send you a link to it and a copy of the slide deck within 24 hours of the broadcast. Today's presenter is Kevin Sutherland. He is Cohesive's, he is a Cohesive's Principal Business Development Manager. And for the past 25 years, he has focused on reliability and maintenance work processes, methodology, technology, and consulting. He is an MBA, CMRP 200 in 2004, a certified RCM2 facilitator, and a certified Jonah in the theory of constraint. And with that, I'm going to turn the presentation over to Kevin.
Well, thanks, Kat, and hi, everyone. Thanks to all for taking the time out of their busy schedules to be here today. I'll just start by saying, hopefully my experience qualifies me for sharing on the asset reliability journey, but I definitely don't have all the answers. I have seen and worked with organizations across the whole maintenance and reliability maturity spectrum. And in that, I have seen what good looks like and what great looks like. There's a ton of angles we could take to talk about reliability, but I decided to focus on the components, or the key steps, let's say, in the reliability journey. And I'm going to share today the way those steps in the journey make sense to me. Just a quick moment on Cohesive. Most of you know who Cohesive is, likely because of our IBM Maximo implementation and consulting approach and practices. In case you didn't know, Cohesive has a world-class advisory consulting group as well, working with clients to improve their maintenance and reliability practices, work processes. So after the webinar, if you want to have a moment with a discussion around your reliability journey, we have a seasoned group that would love to speak with you. So just a couple of thoughts to set the stage. First, reliability, sustained improvement requires a granular approach in processes and asset maintenance data when it comes to measures, hierarchies, failure modes, etc. But we do it because there's value in the granularity. And I'm going to get back to that value shortly. Second, I did a presentation called The Roadmap to Reliability about 17 years ago. So this is a little bit like deja vu. But looking back 17 years ago, the message really applied to leaders in only a certain few industries that were focused and forced to be more reliable based on their business drivers. And what I mean by that, for example, if we look back 50 years ago, the aviation industry was forced to be granular and lead in asset reliability because of public safety. 15 to 20 years ago, oil and gas, petrochem, mining, a few other industries, they had major environmental and safety pressures. And preventing a single hour of downtime in a refinery would put about $1 million in the bottom line. So to make predictable profits and to protect the reputation, they had to be granular. Today, with global competition that we've seen for a while, tightening budgets, decarbonization, ESG requirements, our team at Cohesive is having conversations on reliability with just about every asset and infrastructure intensive business. All types of manufacturing and industry, energy industries, public sector areas like ports, airports, transit, and water, wastewater. So my hope is that today's presentation lands on a fresh audience that's interested in getting more granular. I have an oversimplified kind of an analogy for you. Think just a moment for a taxi cab. It has a seat belt, probably an airbag. You get in, and most of the time you're going to get from point A to point B, even if the check engine light's on. Think about the level of granularity that goes into the maintenance and reliability of the cab and the maturity required. Now think about a Formula One racing car. Team members are calibrating the brakes, measuring combustion, fussing over aerodynamics to get the car to complete a lap 1/10 of a mile an hour faster while keeping the driver safe. So there's a major difference in the granularity and maturity of these assets. So a question for you, along that spectrum, what level of granularity and maturity does your organization ask of you in your reliability approach? My guess that if you're here today, it's probably somewhere in the middle, if not leaning a little more to the side of the Formula One car. So on the agenda, I'm going to start with a quick definition of reliability, revisiting that value topic that we mentioned earlier, proposing a maturity model for maintenance and reliability. The meat of the presentation is covering the key elements on the reliability journey, some closing thoughts, and I hope to have a few minutes for Q&A. Because reliability is such an overused word, I felt we should clarify and include the definition. Reliability was a buzzword way before we were introduced to the buzzwords that we have in the 2020s, like predictive and digital twin. We could get into a lot of complexity around the point or on the definition, but we have a lot to cover. So to keep the definition simple, asset reliability is the probability that an asset or a system or a unit or plant will perform successfully under specified conditions for a given time or period of time. And we can measure that reliability. One way is to look at MTBF. Again, keeping it simple, operating time divided by the number of failures. So if a pump has 4 failures over 10 years, 120 months, its MTBF is 30 months. And turning that calculation into a failure rate, it's simply number of failures over operating time. 4 over 120 equals 0.033 failure rate. Well, why should we care? Like I mentioned in the opening, there's a lot of value in the granularity. If your assets are more reliable, and I mean measurably reliable, not buzzword reliable, it's proven to make and save money and improve compliance, make it a lot easier and help us avoid costly things. So this is a long list of benefits, but just to hit a few high points, improving availability, companies that I've worked with or we've talked to, adding to the bottom line 1% to 2% more production means, meeting orders without having to build another facility, or meeting bus rider demand with 50 fewer buses in the fleet, reducing maintenance costs by 10 to 20%, reducing risk and getting a handle on the unknowns that can keep you up at night, reducing safety incidents, reductions in emission, energy usage, water usage. There's plenty of reasons, why we want to look at getting more granular and reliability. And in terms of organizational maturity that I talked about earlier, let me expand on that. I created a model to characterize organizations at a high level, looking at, do they have established work processes and how well have they been adopted? How well do they adhere to industry standards and regulatory standards? What type of asset documentation is kept and can it be found when it's needed? Do they have maintenance and reliability systems and technologies in place, and how well are they used? And do they have leadership support, staff training, development? So based on that criteria, I characterize organizations as far as how they fit at a high level in the following. At a baseline level, we're primarily categorizing them as break and fix. Number one, overall, they've moved beyond break and fix to primarily having planned time-based maintenance activities and overhauls. Number two, instead of time-based, they're proficient at condition-based maintenance, both doing preventive maintenance based on usage and condition, and in the use of condition-based technologies. Three, they move beyond vendor-provided strategies and what we've always done strategies on especially on critical equipment, and have failure mode-based strategies. Four, not only are they executing on those failure mode-based strategies, but they're collecting and coding orders, failures, downtime to produce bad actors and the best opportunities for defect elimination. Five, the maturity is in place for systematized asset optimization and failure prediction. So a few thoughts before we leave here. Most importantly is it's when we can move from a step 1 to a 2 are from a 2 to a 3 that the value we discuss is realized. And I want to point out, obviously, industry complexity matters. If I manage a taxi company or a couple of car washes, I'm probably perfectly fine living in level 0 or 1. Formula One racing team is probably a 5. So complexity and risk matter. Also, this doesn't mean that if I'm at a level 1, I can't go out and hire a data scientist with a laptop and have him work on predictive algorithms. I absolutely could, and companies do, but that won't make the organization jump to a level 5. I won't have the data and the processes in place to make success with predictive analytics easy or commonplace. So that's a key point. Last, take a moment and think about, where does your organization fall, at a high level on this model? So these are the steps that I picked out, the ones, again, that make sense to me, that fit with my my kind of work and reliability, that require a certain level of attention or granularity to making a step change. I'm not necessarily saying you have to start at 1 and move in a specific order, but this is the way it flows and makes sense in my brain. I had a little fun and I placed them on the cohesive infinity loop. But then I realized that wasn't altogether a bad idea, because in my 9 steps, the end, has us looking directly, back at the beginning. And just quickly, so it starts with stating your goals, getting a baseline of where you are, what KPIs you want to look at for improvement. While we're at it, the foundation of your asset hierarchy and taxonomy needs to be in order, to ensure you can measure well and document well and share information. And then you likely have thousands of assets. Asset criticality helps us focus on where impact will be greatest. Starting with those focus areas, strategy development justifies we're only performing work that's preventing or detecting possible failure modes. It's the right work at the right time. And when we're doing that right work, let's consolidate the outcome, the condition monitoring results from all the different technologies, to have the best understanding possible of health and performance. And those results hopefully show good asset performance. But when things don't go well, it's an opportunity to code orders, failures, and events to find bad actors that slip through the crack. And if we do that well, we can do failure eliminating exercises like, bad actor analysis will send us towards methodologies like root cause analysis. And those bad actors, have an opportunity to be the best targets for statistical optimization or applying predictive analytics. And finally, with our kind of controlled closed loop improvement process, reevaluate your strategy. So look back at the goals and measures. So quickly, that's the 9 steps that I'm going to cover today in some detail. But I did want to point out there are a few areas that I'm not going to cover, and I at least wanted to acknowledge those for awareness. Things like leadership buy-in and sponsorship, those are critical. The journey has to be funded, and most of the time it's going to require a business case with an ROI. It's going to need a charter or a strategic plan, to organize efforts and staffing. There will be changes in work processes like the ones that we're going to cover. Those are going to need change management for adoption. At least an intermediate level of CMMS EAM work process proficiency is required. If you can't do a work order at all, or low level of planning, it's difficult to get to some of these stages. And then, although you will see some screenshots, and I'm not going to mention any specific reliability tools or systems, but those can help with kind of proficiency and efficiency of getting to where we're headed with the journey. So step 1, documenting goals, measures, and KPIs. So our organization has kind of arrived at a place and said, we have to get better, but how are we going to measure better? When will we know we made an impact? This takes getting organizational alignment on, what the measures will be, and getting a firm understanding on exactly where we are today. If we can nail down our performance over the past year, for example, on availability, maintenance costs, downtime, lost production, or generation, maybe mean time between failures, planned versus unplanned work percentage, it'll put a stake in the ground to establish that baseline measure. And just a few thoughts on this step. You may be saying, step one, measure. That's pretty obvious, Kevin. Well, from my experience, it actually isn't obvious at all, or doesn't always happen. So often I talk to companies who, they'll bring in a reliability consulting group. They'll invest in testing tools or software. They start a reliability initiative without taking stock of exactly where they are at the start and how they're going to tell that they move the needle. So imagine spending, your organization's money, people's time over a year, and feeling like you made a significant impact, but not being able to prove it on the bottom line. So your funding gets yanked. I've seen it happen more than I would like. And you may say, oh, okay, cool, agree on the measures, easy, check. But from my experience, getting multiple departments to agree on something like what is downtime, for example, and a single site is tough. You bring in multiple sites and it's a nightmare. One of the key elements here is that, in the end, it's way more important to pick and align on a reasonable definition of things like planned work, unplanned work, corrective work, downtime. Way more important to align on something, just be consistent and get started. And last, there are some resources to help if you're looking for, what makes the most sense for our business as far as measurement. There's industry groups like Society for Maintenance and Reliability Professionals and Reliability Web, for example, that they publicize key metrics for these measures and definitions to help. Some of those, again, are very industry specific. They're really helpful. So step two, increasing maturity in asset taxonomy, or naming and classifying, and improving your asset hierarchy. To be able to track and measure asset performance well, you have to have things like areas, systems, subsystems, and assets named and classified consistently. That way you can later compare pumps, motors, gearboxes, tanks, etc. Work types and priorities need to be set up and used so that they're going to yield an accurate planned versus unplanned metric, or proactive work versus reactive work. Problem codes and failure codes need to be good enough so that we can expect operations to tell us what they see, and maintenance to be able to code exactly what happened. The pyramid diagram on the top left is a graphic used in ISO 142 standard. Even though that standard was created for oil and gas and petrochem facilities, the concepts it uses of organizing and classifying asset data for sharing and reporting purposes, they're valid just about anywhere. So if you haven't seen or haven't utilizing its classification concepts, I'd encourage you to check it out. And speaking of journeys, this step alone takes continuous effort to refine and to get better. Unless you're on the highest end of the maturity model, my guess is that you or someone you work with have said the following. The truth is, I hear this about 90% of the time with our customers. Some even say, hey, our data's so bad, we can't even consider working on reliability. In a simple way, it's kind of like looking in the mirror in the morning. Do my socks and shoes match? Does my shirt and pants match? Do I have toothpaste on my face? Maybe you comb your hair. Like the guys in the picture, is the suit and tie straight? I guess the advice we would have and what we work with clients here on is look in the mirror and start fixing it. And if you need help, again, there's standards, guides, tools, subject matter experts ready to assist. But having the structure set is the way that accurate measures later can be done to see if you're making progress and moving the needle. So step three, asset criticality. And I mentioned before, most asset intensive organizations will have thousands or tens of thousands of assets. Nobody has enough resources to get granular on every asset. So where do you start? It's been a little funny having conversations with companies. I'll say, tell me about your criticality and how you decide where to focus. And sometimes I hear, oh yeah, we thought about that, but we found that everything's critical. And another company once told me, well, some of our assets are critical, and the rest of them are crucial critical. And then a lot of people will say, yeah, we thought about that and we went with gut feel on an ABC. That's probably better than the crucial critical designation. But this is another area where we can look at industry best practices. And for asset criticality, it's a model of the probability of asset failure times the consequence of failure. So the example on the screen, the probabilities are factored 1 to 5. And in this case, the consequence categories used are impact to safety, quality, customer service, and so on. A few important points though, those consequence categories should be based on your specific business needs. So for example, if you're in mining, you may produce quickly, slowly, or not at all, but the quality of what you're mining is usually always the same. So the categories, in some industries don't make sense for others. They should be business specific. A lot of companies will also weigh some categories like safety higher. That's going to help bubble up any asset with safety impact to the top so that they're focused on first. And as far as what the process of asset criticality analysis look like, is typically a cross-functional team of maintenance, reliability, and ops working with a tool. It can be as simple as Excel, considering criticality first at the system level and then drilling deeper to the individual asset level if needed. So there's a couple of major outcomes in criticality analysis. First, most important, it's going to answer that question: where do I focus? And it's going to give you an answer that's justified. The result should look a little bit like a normal distribution curve. So I get a little worried when I hear folks have ABC and they're equally 30%, or when 70% of our assets are A's. Ultimately, the absolute highest criticality is no more than 5 to 10% of your assets. The other major outcome is a list of assets by the raw score of probability times consequence. And that's going to help further point out the highest of the high and the risks that deserve special attention. So now that we know where to focus, step 4 is strategy development. The preventive maintenance, the inspections, the overhauls, the sum of the maintenance work organizations have done up to this point have gotten them the reliability they have today. So if they're looking to improve, here's where to get granular on that work. Vendor recommended maintenance and tasks added over time because of fear of failure, they aren't necessarily bad. They're perfectly fine in a taxi cab example. But when asset complexity and failure risks are higher, legacy strategies usually end up either being too much too soon or too little too late. So the opportunity on your critical equipment is to create failure mode based strategies to only do the required work that prevents or detects the risks to the business that matter. So these are the 7 questions of the reliability centered maintenance methodology for the strategy development, or RCM, if you will. And I'm a fan of reliability centered maintenance on the absolute most critical 2 to 5% of your asset. It yields only the required tasks to retain the functions of your asset and mitigates the risk. But I'm more a fan of reliability centered maintenance thinking in general, because assets that fall into the next criticality group can be candidates for failure modes and effects analysis. And that's the last 5 questions of the RCM approach, as you can see. So FMEAs takes less time, and it's much easier to template the similar assets, especially if you have fleets of assets that are very similar. On lower criticality assets yet, using RCM thinking to say what has or reasonably could cause this asset to fail, and can anything effectively be done to prevent that failure, can create an effective PM review process. It should validate the task you're doing and the frequencies, and it can justify removing tasks that have no value. More than just pure criticality, I would say let your business needs guide you to where to start. For example, if you have surprise failures on critical assets and the risk is keeping you up at night, that's a great place to start with RCM. If you have large groups or fleets of identical assets, that's a great place to start with failure modes and effects analysis. where you can apply one strategy to many assets. And if you have multiple similar sites, have each site start with a different critical system or asset class. They can then take those results and share them, back and forth and move your program along faster. Ultimately, creating and applying your strategies, to your assets and your unique environment is going to become a competitive advantage for your business. That's when the strategies themselves become an asset. So now that we're building strategies in our critical assets, and hopefully we're carrying out those strategies and performing them, we have a lot of great data, that should help us understand when degradation towards failure is just beginning and helping us be more proactive. Except it usually sits in about 20 different databases, websites, emails, filing cabinets, most of it disconnected from where you could create corrective work orders, the CMMS and EAM. So step 5 is about consolidating the condition monitoring elements and attempting to turn this on the top into this. And that might be a little bit extreme, but if given us a bit of an idea about how this can happen, the theme I've heard so much, so often over the years is, hey, the vibration report said we're heading towards failure, but the email got lost and we never created a work order from it. So when the work processes rely on emails, phone calls, and manual steps, sometimes the ball can get dropped at the 1-yard line. So it's also really hard, for example, to put vibration results, lube analysis results, temperature results, all together into context when they're in different places. Some companies, try to assign somebody to pull condition results together manually. For monthly reports like this one, for example, and it's certainly better than nothing, but the problem with it is that it's so labor intensive that by the time it gets collected and circulated, the date's already a month old. So again, if we're talking about consolidating, whether it's something like this, an Excel, a Power BI, here's sort of an example where we're pulling in the results together. In this example, you can see a quick summary of the condition data that I need to focus on and the severity. I can drill down to see more information and correlate it with other data points. And I can even create a work order for repair with some automation. So again, an effort to bring together condition monitoring data and eliminate the manual handoffs is what we're talking about here, and makes a huge difference when you can compare these items together. So having good strategies and good condition data, like we just talked about, should help us move to more planned corrective work and less unplanned breakdown type work. But in either case, whether it's planned work based on condition or if it is a complete breakdown, as I mentioned before, this is an opportunity. I say this is an opportunity for the business to code and to classify exactly what happened. Leveraging the go to work we did in step 2. So the first example is a work order. More mature organizations will write the work order to the right piece of equipment or location, as we mentioned with the taxonomy and hierarchy, have the right work order type and start date, and as best possible, fill out the failure codes, like here, to tell us exactly what happened. The example here is a failure reporting and corrective action system, sometimes called FRACUS, where the failure record is created and it's managed. And here the failure is actually linked to a failure mode that's happened and a problem code. So we're getting closer to take what happened exactly back to our strategy to identify, is that what we expected or not? And on the bottom, it's an example of tracking downtime. Some folks, don't think about this. Some folks have been doing it for a long time, but tracking downtime and potentially calculating lost production, if you can, with a reason code is huge to be able to see what are the top events, to be able to eliminate issues. So why should we do that? Why should we get that granular? Well, because it gives us the absolute best opportunities to improve. the things that either aren't obvious or the things that we have no clue about until we take a closer look. This example was looking at maintenance costs in red, responsibility for lost production in purple, and the combined cost of what I'll call unreliability per major asset is in orange. So if we just looked at maintenance cost in the red and we said, put a team or a person on the highest maintenance cost, we'd be focusing on the fourth best opportunity for improvement and not the first. The example on the bottom is showing selected reason codes by resulting lost production in green, downtime hours in orange, and the number of total incidents in blue. So it gives me the ability to contrast the single mega failure of burned electrical cables with the nagging speed switch issues. They keep happening and happening and happening. I might want to go after both of them, but whichever path I choose, I have the evidence and I know the benefits based on what I can potentially save in downtime and the cost that it's been costing my business. So using that event coding for bad actor lists brings us to 7, defect elimination. This is where we see what slipped through the cracks from our strategies, or potentially where we have a vendor issue or where human error is causing failures. There's multiple approaches to defect elimination, but sticking with the theme of maturity, I believe this is the simplest method. It takes the least maturity, root cause analysis. And now root cause analysis is another term the industry uses very loosely. Some people think that it means, 2 guys standing over a smoldering motor and one guy asks the other, hey, what root cause should I write down? And he answers, just put caught on fire. I'm talking about a structured RCA process with a team who conducts a cause to root cause analysis and then assigns action items to eliminate the root cause from happening again. Now, sometimes organizations are more familiar with this for safety incidents and environmental issues, but the same thought process can be applied to large unexpected failures and to issues from our bad actor list. Many times RCA findings and recommendations are going to feed right back to improving our asset strategy. A perfectly fine, technically correct RCA can be performed on a whiteboard or a wall of Post-it notes. The lower image is an example of an RCM tool, again, to bring some efficiencies, data sharing and traceability. Also, an easier mechanism if you're looking at assigning action items and following through to make sure that they do get done. So another method of picking off the issues from our bad actor list is optimization through reliability analytics. In my opinion, this takes a higher level of maturity because it requires having a few years of reasonably good work order history, failure coding history, and in some cases, downtime history. Yeah, I'll go over a couple of examples and talk about the benefits. So the first example is a Weibull analysis. It's going to evaluate the failure characteristic of a component or an asset or a population of assets. The results are going to indicate how closely that failures correlate to runtime. Failures that typically group around the same time can be managed with a time-based replacement strategy. So if we find a seal that fails always around 3 years, great. How about I just replace it? It might be the cheapest option every 2.5. Asset failures that are characterized as random related to time need condition-based inspection or monitoring strategies to be able to closely detect, if we see failures. So a Weibull analysis is going to be able to help give you the proof and the justification for which of those two makes the most sense. Task optimization uses algorithms to evaluate several possible maintenance outcomes. So for example, run to failure, inspections, or schedule replacements. And it's going to select the least expensive outcome and the optimal frequency to guide back, again, ultimately taking the most care of your assets at the least possible cost. Production analysis, RAM analysis is going to model, RAM analysis models the configuration and the failure characteristics of multiple assets. These are subsystems, systems, and units in a facility, and it uses a Monte Carlo analysis on the model to determine reliability, availability, and maintainability. So it's taking what we talked about as far as a Weibull analysis and bringing it up a higher level to apply on a system over a period of time to give you an idea about what type of reliability percentages or should you expect. How available will my system or my plant be given our existing understanding. And slightly different, production analysis looks at daily production data. So it's the opposite of downtime data measured against the production nameplate of a facility. It yields the reliability of site production. So as opposed to asset reliability, we're looking at a site's production reliability. And it's going to be able to illustrate key tendencies making production suffer and ways you can improve that. So these tools also feed insight right back to our strategies and make them stronger. And just to note, it's possible to use these tools, in the strategy development phase, ahead of the strategy development phase. But it's more typical that companies don't have the quality failure history at that point, and that they'll begin to use these and leverage these tools more as they mature. That's why I put them at this phase. And from my perspective, the most mature method of improving bad actors or big ticket items on hard to detect or frequent failures is predictive analytics, especially using artificial intelligence and machine learning. We're seeing more and more success stories for applying the technology to detect failures weeks and months in advance and to forecast things like future demand. So there's a tremendous amount of promise in this space. The only caution I would say is I put predictive analytics here because even if it's excellent at telling you a failure is coming, it doesn't tell you why. That's the failure modes. And it doesn't tell you how to avoid the failure the next time in the future, which is what an RCA could do. So if companies don't have some moderate level of maturity in those areas, you may find yourself fixing failures early over and over and over and never getting off the hamster wheel. It also takes a certain level of organizational maturity to know where to best apply predictive analytics and how to systematize the rollout. Data scientists, data lake platforms, AI, ML platforms are expensive, and it's best to be able to leverage them really super effectively to be able to to get the value to be the fullest. Just one example, I talked to a mining company just a few months ago, and they went all in on a predictive analytics platform for the real-time data. Their assets are massive in scope. Replacement is hundreds of thousands, if not millions of dollars. And frequently the lead time that they're looking at is months to get a replacement on site. After a year into their rollout, they have more alarms than they can manage. And the best that they're getting is 2 to 3 days early prediction on failure. So what are they doing now? I'm not sure they've learned a lesson, because now they're looking for a predictive analytics platform to put on top of their predictive analytics platform. So from what I've experienced, sometimes the easy button takes a good foundation to really work. And last, we started this journey with goals, measures, KPIs. We put in the work just so we could get to this point. Number 9, reevaluating our strategy effectiveness. And whether we're looking at availability, cost, MTBF, downtime, or whether we're only mature enough, whether we're looking at individual assets or we're only mature enough to track it at the plant level, here is the time where we really get back to that baseline. It's the time to take stock of what's working, what's not. Even if the results aren't what you're expecting, it's critical to know that as well, so you can adjust. When we're comparing things like cost and MTBF, know that they take some time to move, but in the meantime, we can begin looking at leading indicators of change. Percent change in assets with criticality ratings or with strategies, percent of inspections complete, things like number of issues found proactively versus breakdown. And it's possible to do this step in our CMMS or by extracting to Excel, But this is another area where a data analysis tool or system can add efficiency, something that gives the ability to set rules and targets to flag you. If it, things, for example, if it costs will go over a certain level in a certain period, send me an email. If failure count exceeds a certain point over time, or if MTBF decreases, let me know. The flip side of that is an engineer actively going in and researching and looking to see how exactly these elements have changed. So finally, if we're putting resources into the reliability journey, we will be asked at some point by leadership, show me the progress or show me the money. And if we created a good baseline in step one and measure against those targets with our results, we should have hard data, kind of like some of these examples, not just it feels better. So putting it all together, again, this is the way it makes sense in my mind. It's how I see the reliability, journey workflow. Again, determining those goals and measures, improving our asset and coding taxonomy, asset criticality analysis, and these collectively give us the what and how to focus. Now, criticality screening, is to get slightly more detailed here, technically separates or should separate your rotating class of equipment, the rotary things, motors, pumps, gearboxes, from the fixed and static equipment and from the electrical and instrumentation. And on the things that fall under rotating balance of plant, again, based on high, medium, low, we can apply the right method according, RCM, FMEA, or PM optimization. Safety critical fixed equipment should fall under a risk-based inspection program. And safety critical instrumented functions should fall under a safety instrumented system program. So collectively, our strategy development layer. No matter the methodology, they all produce inspections, tests, and monitoring actions. A lot of these things, even though they may be done differently as far as the way they're tested or end up in different systems, it's all trying to detect degradation. And collectively, I would say that is our proactive condition-based task and monitoring. So now the time comes, we execute or do the condition tasks and monitoring, and at the same time, corrective work is being done. Production, generation, operations is happening. It's the execution layer of our business, and that yields the readings, the data, events, alarms, hopefully consolidated, as we discussed. But it also yields work order history with costs and dates. It should yield operation results, sometimes including downtime and losses. And when our condition data does yield an alarm, it should go right back and create a planned corrective work order. In each of these outcomes, it's our opportunity for good event coding to ID the best opportunities for improvement. How does it? I designated this area, the results area of the business. And again, in my opinion, root cause analysis is the lowest cost, lowest required maturity level method of defect elimination. And recommendations should go directly back to improve our strategies. The next improvement method, optimization with reliability analytics, where we're using historical failures to form insights on future performance. Recommendations here should likewise go directly to improve our strategies. And then predictive analytics. And again, I positioned it here because opportunity identification can tell us where to apply the technology to have the best bang for the buck. And I have it here, I guess another way of saying it is the cherry on top, not the main course. Now, predictive analytics reports back, in this case, to our consolidated condition monitoring, as an early alarm, which should kick off a planned corrective work order. And I'm calling that the improvement layer. And finally, that cost, production, and failure results, it should help reevaluate the performance of our strategies against the baseline and the area of focus. It should tell us Here's exactly what costs or failures or availability or reliability we had versus what we had expected. It should validate our asset criticality decisions and potentially say, wow, we had a major issue on this compressor. We had it marked as a criticality C. Now we know it should be an A. So it's gonna feed back into the business and help make all the initial, sometimes assumptions, be data-based. So again, this is the way that I see the process flowing and working for each of those steps, getting granular. Progress in some of these or many of these, again, that's what leads to that maturity model step change. So just a couple of final thoughts. Reliability is a journey, not a destination. It's sort of like a pursuit of happiness. It's going to take daily work. And despite it being a buzzword, though, we can define it and exactly what it is, and we can measure it. Getting granular and the steps that we presented will support making that maturity step change and moving up a maturity level. That's what's going to yield the savings, production, and managed risk. And finally, whether you're about to start on your reliability journey or if you're well on your way and you have questions, my colleagues and I at Cohesive, we invite you to connect with us for a discussion. And with that, I will open it up, Kat, to questions.
Great. Thank you very much, Kevin. I appreciate that. Do have just a couple right now, and we've got about 15 minutes left in the presentation, so I'm not sure how in depth we'll get on some of these, but the first one is, what is the best type of root cause analysis?
Good question. I've seen effective root cause analyses done with things like methods like 5Y, Fishbone, methodologies like PROACT and cause mapping. So I would say, there's not a specific type that I would say is the best. I think Cohesive believes they should be structured. They should have a team making sure that all the voices in the room get heard. No one is dominating the process facilitation, and also making sure you understand and evaluate all the possible causes, just so you do get to a root and don't end up at a shallow cause like that it caught on fire type example. So yeah, I think it's a lot of good approaches. It just needs structure.
Okay, good. Another question, looks like it's a two-parter. What is involved in a reliability assessment? Do you propose areas where there is an opportunity for improvement?
We do, yeah. So Cohesive Advisory Services absolutely does maintenance and reliability assessments, and even broader digital transformation assessments for clients who are looking for other directions. But we certainly go in and look at elements like I've mentioned today, like I proposed as part of the steps of the journey, categorize maturity on those individual items, point out areas that that can get better and what that would yield to the business, and even point out some areas where, hey, this probably the juice isn't worth the squeeze here, where the effort is not going to yield the best satisfaction or savings in the end. So absolutely, we do offer assessments. They point out sort of lightning areas of focus where we feel like they're the best opportunities to improve. So yeah, let's talk.
Cool. All righty. Does not look like we have any additional questions. Oh, we did have someone, a very good presentation on reliability. Thank you. How do you think the 9 steps map with ISO 5501 requirements? Can we get a copy of the presentation? We will be sending out a copy of this presentation out within 24 hours. So I'll answer part 2 of that question. And Kevin, did you catch what I was trying to prattle on the first one?
I think so, yeah. So ISO 55001, absolutely. I think the easiest way to summarize, that is of line of sight. And I think, when I mentioned some of the things that I wouldn't cover, it's that, there's a lot about that ISO standard involving leadership, involving your asset plan. But when it gets down deeper into the elements and into the structure of the plan, I think that these elements map really well. Again, when it comes to creating the taxonomy, the things that you're going to measure, controlling, measuring. I didn't really mention, ways to measure risk, although we talked about criticality assessment, but definitely measuring risk and giving a line of sight to business. I think from the tactical perspective, it maps really well to the ISO standard. And we have folks on our team at Cohesive who actually sat on the standard when it was going through reviews. You can know that really well from both perspectives, the tactical and the strategic.
Great. I think that was the final question that we had. So this concludes today's webinar. I want to thank everyone who attended today, and I trust you found the presentation of interest and value to your organization. If you have any other questions, please don't hesitate to dash Kevin an email. Kevin, if you could advance your screen one more. We will make this presentation and a copy of the slide deck available within 24 hours of the broadcast. Thank you, and we look forward to seeing you on our next webinar, Time to Rethink Maximo, the benefits of hosted MaaS and managed services, on July 6th, hosted by Jeff Yazinski. Thank you very much, everyone, and have a wonderful rest of your day.